This module presents an overview and shows the location of the major components in the 767 air data system. The purpose of the air data system is to measure conditions of the air mass next to the airplane. Using inputs of pitot pressure, static pressure, angle of attack, and total air temperature, the air data system provides information on altitude, airspeed, temperature, pressure, and angle of attack. Finally, there are anti-ice heaters that prevent icing on probes and sensors. Each of these systems will be reviewed in more detail, but first we will divide the air data system into two sections, pneumatic and electrical. The pneumatic portion involves the pitot and static pressures and includes the devices attached to the pneumatic lines. The electrical portion starts when the pneumatic pressures are converted to electronic signals. This includes the electrical signals coming into the air data computer and those generated by the computer, which are used throughout the airplane. The electrical portion also includes the probe anti-ice circuits. Each of these will be examined in more detail, starting with the pneumatic portion, followed by the electrical signals, and finally by the heating circuits. The pneumatic portion starts with probes and ports for sensing air pressures. There are 4 pitot-static probes, 2 on each side of the fuselage at body station line 200. The forward-facing probes sense total or pitot pressure, while the port openings on the side of the probes sense ambient or static pressure. An alternate static port is flush-mounted on each side of the fuselage. These provide an alternate source of static pressure for the air data computers. The probes and ports are connected to tubing inside the airplane. These carry air pressures to the standby indicators, the air data computer, and to other systems using pressure inputs. The tubing is color-coded. Red indicates pitot pressure lines. Yellow represents the static pressure lines. To remove condensation inside the tubing, drains are located at the lowest points of the lines. These drains are concentrated in 3 areas of the airplane: on both sides of the forward equipment center, on both sides of the main equipment center on the support columns of the electronic racks, and in the aft cargo compartment. Pressure lines connect the probes and ports to several pressure-sensitive devices inside the plane. These devices are cabin differential pressure, standby altimeter, standby airspeed, elevator field computer, and the air data computers. The elevator field computer is mounted in the stabilizer jack screw area. Access to this area is through the stabilizer access door on the bottom of the fuselage. The elevator field computer calculates the resisting force applied to the control column as a function of airspeed and stabilizer position. The cabin differential pressure gauge and the 2 standby instruments for airspeed and altitude are located on the flight deck. The standby altimeter and standby airspeed indicator are located on the P1 instrument panel. The differential pressure indicator, which indicates the difference between cabin pressure and outside ambient pressure, is located on the P5 overhead panel. Other pneumatic components located on the flight deck are the static source selector valves. These selectors allow the pilots to switch the source of static pressure for the air data computers. Normal static pressure is from the pitot-static probes. Alternate static pressure is from the alternate static ports, which are flush-mounted ports aft of the probes. The final pneumatic components are the air data computers located in the main equipment center. Access is through a door just aft of the nose wheel well. Located on the E1 rack on the 3rd shelf is the captain's air data computer. The air data computers are also the first component in the electrical portion of the air data system. They convert pitot and static pressures into electronic signals. Other inputs into the air data computers are angle of attack and total air temperature. Angle of attack vanes on the forward portion of the fuselage resolve the direction of airflow into a servo signal as an input to the air data computers. Total air temperature probes in front of the pilot windows convert air temperature into an analog signal also used by the air data computers. The air data computers use these three basic inputs, pressure, temperature, and angle of attack, to calculate the air data parameters. These parameters are sent by ARINC 429 buses to systems throughout the airplane. The primary electronic air data instruments on the flight deck are located on the P1 and P3 panels. These are the pilot's altimeters and Mach airspeed indicators. Also located on these panels are the air data switches. These switches allow either pilot to select output data from either air data computer. On the P61 accessory panel is a switch to test the air data computers. By placing this switch right or left, the appropriate computer will send a standard test signal to its respective air data instruments. The anti-ice circuits are the remaining electrical portion of the air data system. Heating coils and control circuits prevent icing of the pitot-static probes, angle of attack sensors, and the total air temperature probes. Automatic controls for the heater coils are located on the P33 panel in the main equipment center. Probe and sensor heat controls are automatic upon engine start. A fault within the system will illuminate amber annunciator lights on the P5 panel, and a message will appear on the maintenance display of ICAS.